Welcome. If you want to understand not just how to create method extensions, but when to create them, then this tutorial is absolutely for you. Before creating this tutorial, I spent some time on YouTube, but realized that there are tons of sources related to method extensions, but approximately 99% of them is just mess. So there is no real world example of using method extensions. They are just using, the string ones, also the duck, monkey classes. So it is absolutely a mess, but this tutorial will help you not just write method extensions, but from the development perspective, create better method extensions, and you will understand when you need to create them. So first things first, I have agenda for you. The first element here is why method extensions. Before diving into details, we should understand in which scenarios we need to create them. The second step here is the real world examples. I will show you the approximately real project, and using this real project, you will understand in which business scenarios you need to create method extensions. So let's go with why method extensions. Method extensions helps you to extend third-party libraries. Say you have, Mediator, Swagger, the other third-party libraries you are using in your projects, popular ones, you can take any of them, but you want to add some additional functionality over this library. So library provides some type of functionality, but it is not completely enough for you to implement it, or configuring this library, preparing the things you need from this library takes a lot of time. It means it is time to use method extensions. The second one is adding domain-specific functionalities to your existing types. Say you have some class. In our scenario, we will have account type of classes, or it can be a cart class. So you are using these classes in different projects. One of these projects requires you to do additional operation on this class, but the other ones stay same. It means you need to apply method extension only for the specific project. If only one of the project requires you to add some type of functionality, you shouldn't do rewriting on your code, on your original source code. Using method extensions, you can extend your class, even reaching out it is source code. Third one here is method extensions helps you to reduce code duplication. We'll see a little bit later this feature. Using method extensions, we will reduce code duplication. And of course, reducing code duplication, creating a better structure using extension methods improves code readability. So it is time to switch to the project. It is enough theory. Let's see. We have Visual Studio project here. I've created just simple project, but this project approximately the nearly real world example. In my case, I have API layer. This is Web API .NET 7 Web API project. I have services layer. The services layer has contracts, implementations. Contracts here just interfaces and their implementations. I have API layer which uses these services, and also I have common library. I have just moved my models to common library to make it reusable from different layers like API layer, service layer. In my case, I have only one controller here, and it is account controller. I'm using dependency injection to inject account service here. The responsibility of account controller is just provide account information to the user. So we have only 3 endpoints here. Actually, it is active account, getting active accounts with parent ID, and also retrieving all this information in CSV format. We'll do a lot of refactoring here, and we'll understand how to use method extensions. Actually, that's not all. I also have program CS, and this program CS I have added mediator for loosely coupling, I have added Swagger documentation, I have added service layer, services as a dependency injection elements, and also I have cache controlling and plus global exception handling. Let's see. We have add mediator and we are doing some type of configuration for our mediator. I won't use this mediator functionality. This mediator functionality actually may require additional configuration, but I want to encapsulate this mediator and want to use it only like this. Builder.services add mediator, actually without any configuration, but under the hood I want this add mediator functionality to use this configuration. It is also applicable for add Swagger generation. I want to make my Swagger usage only like add Swagger, and this interface should be enough for me to run my application, because when I open my program CS, I don't want to see the implementation details, the configuration details here. And maybe I will use this functionality, this configuration in my other projects. So per project, I don't want to do copy and paste. I just want to write add Swagger, and behind the scenes, Swagger should use the same configuration for all projects. So how to deal with that? Unfortunately, we don't have direct access to mediator. So from the first glance, it seems not impossible to implement it, but actually using method extensions, we can easily extend our third-party libraries. Even add mediator is a third-party library, but I can write a wrapper, a decorator over mediator using method extensions. Let's go for it. I'm going to create a folder here, add folder. I actually created a folder here, and it is going to be our extensions. I will create a new class here. I will explain the problem details factor extension a little bit later. Let me create a class, and I will call this class service extensions. Why? How you define the name of your extension class? It depends from your extension functionality. Actually, in my case, I am extending my service functionalities. Why? Because in my case, I have add mediator, add Swagger generation, and they are a part of service collection interface. So I am extending service collections. So it is better to call it service collection extension. Actually, it should be service collection extensions, but in general it doesn't matter how to call it. At the end, you will only reach out to the methods rather than direct class name. Okay, now we have service collection extension, and I want my application to be look like similar like this: the service.add mediator, services.add Swagger. So how to make this code to be workable? I just need to extend a service collection extension. So the service collection interface, the service collection interface is a black box for me, because this is a third-party library, that is a Microsoft provided library. So you need somehow to decorate it, you need somehow dynamically create a method, not inside it is code, but let's say literally make Visual Studio to understand that there is a method for a service collection. This is actually called extension method. So let me type. All extension methods should be inside in our static class. Public, static, and for the static classes, all the methods inside this static class should be static. So let's see, we need to extend our service collection. I'm just typing void for now, but I will show you how to make it buildable. And the method name is going to be add mediator. Okay, add mediator. We are extending our service collection interface, so automatically you realize that Visual Studio can detect that we are trying to extend some type of service collection. It is actually iService collection extension. Using this keyword, we define that to which interface we are planning to add dynamic functionality. It is going to be for iService collection, service collection. And that's all. I'm just going to copy this builder site from here and type service collection dot add mediator. That's all. Now I'm just going to comment it and see if there is add mediator functionality. Actually, there is add mediator functionality, but in my case, I'm typing it with R here to not to match with mediator method. So it is add mediator, and let's add using extension methods, demo API extension. So this is our extension method, and Visual Studio could resolve it, and it says that you should use this namespace and to make your code workable. And now that's all. Add mediator. Let's right click, go to definition, and you see we have add mediator functionality even I don't have access to iService collection interface itself. So I could easily add a method to a third part library. In my case, it is iService collection interface. Cool. Now it is time to apply this behavior for Swagger also. The same functionality will go for Swagger. Let's copy this. Let's go to service collection extension, public, static, void, add Swagger. Actually, it is not correct to provide void for this extension method because service collection works with a building mechanism. So this actually should return this service collection to make it buildable. Okay, so it is returning iService collection. I am providing iService collection. Otherwise, chaining this method will not be possible. I will show you this chaining mechanism right now after typing this method. This iService collection, service collection. I am going to extend this service collection interface. Okay. So let's type service collection dot add Swagger, and let's add missing namespaces in my case. Cool. Seems really great. Refactoring. Add Swagger. Now it is possible to use, so we already have this add Swagger. Let's remove this one. Unfortunately, this add Swagger is in void type. It returns void type, so it will not be possible to us to add transient, add scoped, or other methods plus extension methods for this service. For that reason, we need to return this service collection from here and to define iService collection interface as a response. Cool. Now everything is ready. Okay, let's see another refactoring where we need extension method usage. In my case, I have service layer here. For my service layers, I provided all the services directly in my API. I need somehow isolate and move all this functionality to service layer itself, because providing these injection methods is a responsibility of service layer rather than API layer. So service layer should configure for which interface it needs to return which implementation. But in my case, it is just mess, and it is directly in my program CS. What I'm going to do here, I'm going to create a new folder in a service layer and calling it extensions, and this extensions is going to be a service extensions. Okay, my service extensions class will extend iService collection, and the responsibility will be moved from the API to my service layer. I'm just going to do the approximately same operation here: public static and public static iService collection. Actually, Microsoft did a lot of good stuff regarding to the libraries. They provided lightweight, rather than providing a big huge module, they provided small modules like Microsoft extensions, dependency injection, abstraction. It actually helps me to inject a partial module, a partial implementation of ASP.NET to any layer I want. So I'm just going to add service, or you can call it register service, register services. I think that should be okay. Register services, and let's just cut this functionality from here and type like this: services dot add transient, and return the exact service we already injected. And let's remove unwanted namespaces, and let's call register services. And of course we need the namespace for it. We have namespace extension methods demo services extensions. I am going to add it using like this, and that's all. So extension methods helped you in this case to do responsibility oriented development. I mean, you moved responsibility from the API, because the API's responsibility is not to inject these services, because the service layer itself should be a main root detector of service implementations. And in my case, I moved functionality from the API layer to the service layer. And now when you go to definition, you see that we have reference to this services. Now it is okay. We did a lot of good refactoring here, and it is time to do additional refactoring toward API layer. In my API layer, I have cache control, and I'm doing a lot of complex stuff here. I have chaining to provide functionality in my middleware. I want to make it a little bit easy, and our developers don't need to understand what's going on inside this cache control. Instead, they should understand that I'm just using cache control. Okay, use cache control. That's all. For this reason, I need to extend, let's say this is our web application class. The web application class is also a black box for me, and I don't have access to its source code, but I can do the same extension behavior for the web application also. So I'm going to create another class here, and I will call it web application extensions. And it is actually a static, because for the extension methods you must create static class. Every extension method should be a static, and first argument should be used this keyword, public static. Let's see, we have actually what we have here. We are returning application builder. In my case, actually doesn't matter. I can just return it easily. Application builder. Okay, let's go with application builder. Use cache control, and it is not actually application builder but web application. Cool. Now I'm just going to cut and just paste it here. Nice. And let's return response, and let's try to use cache control. Well done. Now we already typed it, so we have use cache control, and it's really easy for the other developers to see that we have caching. But how we implemented it, it is a black box for our developers also, and using goto definition they can easily, of course, configure it. Let's try build our application and see if everything is buildable. Cool. Rebuild all succeed. Now let's go to our program file and see what we need to do here as an additional operation. As you see from the implementation here, from the writing style here, it is really easy to understand this code, but before there was a lot of quite complex configuration in my case, and unfortunately this made my life hard. But using this one, it is really easy. Using extension methods, it is really easy to understand it. Of course, the last thing here is let's refactor this one also. I'm just going to web application builder and going to copy the signature here and just copy this functionality from here to my extension method and returning the response. And the functionality, of course, will be use global exception handling. Nice. Now let's use it. Application dot use global exception handling. It is actually handling. Use global exception handling. Okay, we did a lot of refactoring using method extensions. This is a real world example how nowadays I am writing as a code. I am writing as a software engineer, of course. And I think that's all from the program CS perspective. The only thing I want to mention here is the method extensions also helps you to make your method signature really easy. Instead of using the problem details, create problem details with some type of value, I just created a wrapper over it, and create not found details is easy for me to understand rather than providing some type of values here. So using method extensions, you can easily make your application interface understandable, more readable, rather than providing a lot of values and defining a complex signature. Okay, cool. Well, I think that's all related to the API layers program CS. But now it is time to switch to account controller. We have a lot of stuff today here. So my account controller have get accounts functionality, and using this get accounts, I'm returning all the account information. Let's first try to understand this service. This is just dummy service. This there is no repository or data source here. I'm just returning a static value, and for my account it is not anemic model, but it is real domain model, and this domain model has 4 properties. For our account, we have account ID, account number, is disabled, and root account ID. And using change account number, we are changing account number and we are checking if it is enabled. If not, then we are enabling this account. It is really easy. You can create any other classes, or you can apply this principle to any of your domain models actually. Well, I have the first action here is I'm just going to the service, retrieving all the account informations, and using for each, I'm checking if this account is not disabled, then take this account. It means I need to get all the active non-disabled accounts. I only have get all accounts, and let's take into account that this account service is a third part service. Okay, it is not your service, it is third part, or it is your service but you are consuming it via NuGet package, or in your case, from the business perspective, you shouldn't do any changes directly your source code, but somehow extend this service to provide additional behavior like returning active accounts rather than all accounts. Okay, now it is time to add some type of extension methods, and I don't want to use this functionality. Actually, implementing the business in your API is really code small, and you need to avoid to doing the business operations in your service, in your API layer. You should move all these functionalities to your service layer. But from the method extensions perspective, from the learning perspective, it is completely okay for us. And I want to use some type of this signature for my implementation. It should be get active accounts asynchronously. And this method, of course, is awaitable and return. That's all. I want to refactor my code and to make my application to return directly active accounts rather than in my API to do additional operations. How I can fix this issue and to make my interface to look like this? It is actually really easy using method extensions. Okay, let's add a new extension to our service layer. It will be called account service. Account service extensions actually. And public static. My interface in this case should look like public static task enumerable account get accounts, get active accounts. Okay, and let's add a reference to our accounts, and let's try to deal with this issue. I'm just going to copy all this functionality and paste it here. Now I have direct access to my account service. Actually, this account service is, you can inject it, account service, or you can directly call it. In our case, it doesn't matter actually for us. I'm just going to call it directly new account service. New account service. I think it is a default account service, sorry. Default account service. Okay, now we are awaiting this default account service. Let's see, this is awaitable. Okay, and my method should also be async await, should also use async await pattern. In this case, I'm retrieving all the accounts. I'm doing for each. It doesn't matter for now to refactor this part of code. It is important to understand how we are applying method extensions rather than fixing the code smells from the business perspective. Okay, so we have all accounts. We are doing a for each, we are adding it, and we are returning them. Actually, we already have a good collection of extensions like LinkQ, and LinkQ relies on extension methods. In most cases, Microsoft is using method extensions in a life-changing manner, and LinkQ is one of them. But we are avoiding LinkQ now because we want to understand how extension methods should be used from the real-world example perspective. And now it is time to remove this code part from here. Okay, and now let's see why we get active accounts. Get active accounts asynchronously. I think this is our account service actually, because I need to add this extension methods to my account service. I forgot to add it. Account service, and actually you already have this account service, and sorry, no need to do like instantiating. But if you need any other service, you can instantiate it, or directly from the method arguments you can accept it. Okay, now we have this extension method here. Okay, account service, let's try to add it. I just want to go to the extensions here and using service extensions. Now it is okay. We have one simple method as an extension method, and now it is possible for us to do a code refactoring to reuse this functionality in other part where it requires to be used. Well, we have two other methods here to be refactored. The one is approximately similar to get active accounts because we are getting active accounts, but in this filter, I'm doing additional filtration for root account ID. This is approximately same, but here we have additional behavior. We have additional business logic to check root account ID. How to deal with that? Of course, we'll use a delegate based extension methods to deal with this issue. Okay, so let's try to do it. I may use any other filter here, and for that reason I will try to implement it using a func delegate. So I'm just providing a func delegate here. This func delegate will accept account and return boolean. It is actually a predicate for us, and if only the predicate, when only the predicate returns true, we will go further. Okay, predicate. Now we have predicate. Okay, let's go with this predicate. I am providing this account for this predicate every time, and if this predicate returns true, it means it is okay. Let's take this account. Now in my signature, I need to provide x dot is disabled, is not disabled. It means x is not equal to false. And let's try to use the same one for account, root account ID equal to parent ID. In my case, it is going to be X, and now I can easily refactor it. Cool. So you see, method extensions really helps us to do real world refactoring, and it is obvious that how we are using these extension methods in our real project. The last one here is actually getting information in a CSV format. So we may return not just account information, but in my case, I have other data type here called card. So I want to return this CSV information for account, for card. I want to extend this functionality to be used by any other types we have. So it is possible for your account to return in a CSV format, to be returned in a CSV format, for your card to be returned in a CSV format. So how to deal with that? It is actually really easy. Let's go for it. I have API, I have extensions, and I am going to create another service collection. It will be called CSV extensions. Okay, for the CSV extensions, I will add one single method, public static. Let's see, the purpose of CSV here to be returned as a string format, in a string format. So we are using the reflection, we are getting type here, we are getting types properties and the properties values to make a CSV format. So the CSV format should be applicable for all other types. It means let's copy this one. I have all accounts. For now, I will apply it for account, but using generic types, of course, you can apply it for all your other types. String CSV. Let's paste it. I have account service. For the account service, I want to extend this service extension to make it to work with, let's say, account service. Okay, I have account service. This is going to be this account service. Now I have account service information. I have get all accounts, and I am doing, let's see, for the get all accounts, what we have. We don't have any other arguments here, so it should be async instead to use await. And we have account information. We are doing CSV format and we are returning it. But in this case, it says that something we are missing here is a task string. Okay, and let's try to use it now using await account service as CSV asynchronous. Let's call it like this, as CSV asynchronously. Okay, I am going to refactor the extension here. Of course, this CSV, you can move these actually to an account service extension. I will do it a little bit later. CSV, let's copy the functionality from here and let's go to extensions, account extensions, and let's move the functionality directly to the account service itself. Now I will be able to remove this class here and will easily use the functionality. Now I have all the required information, and now my method can return the exact CSV format. Now everything is completely ready, and this was our lesson related to method extensions. I hope I could explain method extensions in C#, and using method extensions we did a lot of refactoring. We understand that we need to use method extensions when we need to extend some type of third-party library, or even it is our library, our class, but from the project specification it requires additional functionality which we don't want to add to our project, and also method extensions helps us to extend some type of classes and to do additional refactoring, to reuse it and make our code more understandable.